In this class, now I am going to explain you factorial of a natural number n, and also I explain you 4 applications based on this factorial of a natural number, so which are very useful in this IIT-JEE preparation. And before going to learn this factorial of a natural number concept, today 26th January, auspicious day to all of us. So on behalf of this day, now I am wishing you a happy Republic Day to all. Now let us go to the class. Meaning of a natural number. See, now here we would have to learn factorial of a natural number n. So this is the factorial symbol, which means that continuous product of first n natural numbers. Continuous product of first n natural numbers. Here 1, 2, 3, all these are natural numbers. Natural numbers begins from 1, 1, 2, 3, 4 and so on, n minus 2, n minus 1, n. So this is the fundamental meaning of factorial of a natural number. Continuous product of first n natural numbers. Even this can be also written as n factorial is equal to n into n minus 1 factorial. N into n minus 1 factorial. See here, suppose if you require 3 factorial, which means that what? We would have to multiply 3 to 1, which is equivalent to 6. So suppose if you require 4 factorial, so now continuous product of first 4 natural numbers, 4 into 3 into 2 into 1, so which is equal to 4 3 is 12, 12 2 is 24. Similarly 5 factorial, so 5 into 4 into 3 into 2 into 1, now 5 4 is 20, 20 3 is 60, 62 is 120 and so on. So even 6 factorial, so it can be written as 6 into 5, here it is, you can stop 6 into 5 into 4 factorial, here itself you can end, because here we mentioned with factorial symbol, otherwise still 1 you can write 6 5 4 3 2 1. Suppose here 5 factorial, now it can be written 5 into 4 factorial also, because here we are using this factorial symbol. If you remove this factorial symbol, so it should be written till 1, like 5 4 3 2 1. So here in the same manner, n factorial can be written as n into n minus 1 factorial, in which both sides put n equal to 1. If you write here 1 factorial, which becomes 1, 1 minus 1, 0. So 0 factorial. Now 0 factorial is equivalent to how much? 1. I hope you have understood the meaning of factorial of a natural number. What is the meaning of factorial of a natural number? The continuous product of first n natural numbers. Continuous product of first n natural numbers. So here 3 factorial, 6, 4 factorial, 24, 5 factorial, 6 to 120 and 6 factorial, you will get 720 and so on. Now let us learn 4 applications based on this factorial of a natural number, so which are very useful for this IIT-JEE preparation. Now let us see that 4 problems. See, what is the power of 2 in 100 factorial? Exponent of 2 in 100 factorial. Here 2 is a prime number. Here they may give you 2, 3, 5, 7 and so on. Any prime number is given, so you people have to follow this procedure. Exponent of 2 in 100 factorial. See here, exponent of 2 in 100 factorial. Here they may give you any prime number. So you people have to follow the same procedure. See here, you have to apply greatest integer concept to find the exponent of 2 in 100 factorial. So you would have to write like this: 100 by greatest integer of 100 by 2 plus greatest integer of 100 by 2 square, greatest integer of 100 by 2 cube, greatest integer of 100 by 2 power 4 plus greatest integer of 100 by 2 power 5 plus greatest integer of 100 by 2 power 6. Next, greatest integer of 100 by 2 power 7. Here itself you have to stop it, because you know students, so till here inside, till here you got a proper fraction, means numerator value is smaller than the denominator. Sorry, improper fraction. Here these will be improper fraction inside. So here 100 by 2, numerator is more than the denominator, improper. 100 by 2, numerator is more than the denominator. 100 by 2 cube, numerator is more than the denominator. Hence, so which will be improper fractions. If you convert them into the decimals, you will get more than 1. Am I right? So, but here, from here onwards, 100 by 2 power 7, 2 power 7, 128. We are getting from here onwards proper fraction. When you convert the proper fraction into the decimals, you will get 0 point something. That answers will be from 0 to 1 only, which means that, so, okay, if you find whose greatest integer, that results will become 0. So that here itself you people have to stop. Okay. So here, like this, you people have to write to find the exponent of 2 in 100 factorial. Up to where you have to write? Until you will get proper fraction inside of this greatest integer symbol. So now simplify. 100 by 2. 100 by 2 means 50. Greatest integer of 50 is 50 only. Now go here. 100 by 2 square. Now 2 square value 4. 100 by 4, 25. Next come here. 100 by 2 cube. 2 cube value 8. Now when you divide 100 with 8, so you will get, see here, 100 divides with 8. 8 1 is 8. Now 2 0. 8 2 is 16. Okay students. So how much is left? 4.0. 8 5 is 40. Remainder is 0. What is the greatest integer of 12.5? Which becomes 12. Next, see here. 100 by 2 power 4. 2 power 4 value 16. So 100 by 16. 16 6 is 96. So that you will get this quotient is 6 point something. 6 point something means whose greatest integer value is 6 only. You know, if it is 6 point something, you would have to take only integral part. In the integral part, we will get there 6. So that here only integer will come. That integral part must be written over here. Now go here. 100 by 2 power 5. 2 power 5 value 32. 100 by 32. If you simplify, you will get 3 point something. 32. 3 is 96 no? So that here you will get 3 point something. Greatest integer of this 3 will come. Now here 100 by 2 power 6. 2 power 6 value 64. 100 by 64 1 point something. Greatest integer of this is 1. Now from here onwards you will get all zeros. So that these terms not required to write. Now add all of them. So 50 plus 25, 75. So 75 plus 12, 87. 87 plus 6, 93. 93 plus 3, 96. 96 plus 1, 97. So the exponent of 2 in 100 factorial means here if you express 100 factorial in prime factorization, so you will get to 97 in the power of 2. Here and exponent of 2 in 100 factorial. Actually 100 factorial means you have to multiply from 1 to 100. And if you express all of them in the prime factorization, so in the power of 2, how much do we get? 97. So this is our required answer. Exponent of 2 in 100 factorial. What is the fundamental meaning of exponent of 2 in 100 factorial? Actually, generally we use it to multiply 1 to 100. That is very difficult to multiply. So like 100 into 99 into 98 till 3 to 1. And you would have to write all those numbers in the power notation, prime factorization. You know how to express composite number in the prime factorization. Okay, if you write like that, so after simplification, so the power of 2 we will get something. How much is that? So how much is that? 97. To writing all those numbers and expressing them into the power prime factorization and simplifying, that is very big task. So with the help of this greatest integer concept, in the easy manner we can answer to this question. I hope you have understood this. Exponent of 2 in 100 factorial. Now let us learn one more question. Exponent of 5 in 100 factorial. Exponent of 5 in 100 factorial. Same like previous one. See here, 100 by 5 plus 100 by 5 square. 100 by 5 cube. Here itself you people have to stop it, because the denominator here proper fraction came. When you simplify this one, so we will get 0 point something, hence all these terms will become 0. So now simplify this. 100 by 5 which becomes 20. Now 100 by 5 square 25. 100 by 25 24. So the exponent of 5 in 100 factorial is 24. Now next question. Find the number of zeros at the end of. Find the number of zeros at the end of 100 factorial. 100 factorial. 100 into 99 into 98 into 97 into till 3 to 1. If you multiply all of them, so in the result, okay, which ends with how many zeros? This is our question. Again, writing all those numbers and multiplying is very big task. Okay, so with the help of this factorial concept, easily you can answer. But to answer this question, you would have to know previous two problems. What is first problem? Exponent of 2 in 100 factorial. See, 100 factorial, if you write, so you may get 2 power 97 into 5 power 24 you got. Like many more numbers will come here, 3 power something and 7 power something, like next prime number 11 power something and so on will come. But here what is our question? Number of zeros at the end of 100 factorial means, you know, zeros will form by 1 to 15. See here, if you take 1 to 15, whose combination, whose product will be given 1 0. So suppose if you take 2 square 5 square, here we collected 2 2's and 2 5's, then whose simplification will be 100, ends with 2 zeros. Suppose if you take 2 cube 5 cube, now 5 cube 125, 2 cube 8, 125 8 is a 1000. So here if we collect 1 to 1 5, we are getting 1 0. Here 2 twos 5, 2 twos 2 5s, we are getting 2 zeros. Here 2 threes, sorry, 3 twos 3 5s, we are getting 3 zeros. Here 1 2 1 5 1 0, 2 twos 2 5s 2 zeros, 3 twos 3 5s 3 zeros, like this. Okay, now it can be written 2 power 9, subtract 24 from this. So here if you subtract 24, here it is going to be 7, here it is going to be 3 into 2 power 24. You can write this one. 2 power 97 can be written 2 power 73 into 2 power 24 into 5 power 24 and 3 into 7, like many more prime numbers will come, but this combination will be given zeros. Okay, so right now 2 power 73. Now here it can be written 2 into 5 whole power 24 and 3 into 7 into and so on. Now 2 5s are 10. Now 10 power 24 we are getting. Hence this result ends with 24 zeros. 2 5s are 10. 10 power 24 you are getting. 10 power 1 ends with 1 0. 10 square ends with 2 zeros. 10 cube ends with 3 zeros. Like 10 power 24 ends with 24 zeros. Hence this result ends with 100 factorial. Ends with 24 zeros. I hope you have understood. We have to tackle this problem. First you would have to find exponent of 2 in 100 factorial. We have seen. And exponent of 5 in 100 factorial. We got this much. Now this 100 factorial ends with how many zeros means for this third question you have to take the combination of these 2 and 5 exponents. Now here remaining prime numbers will not form zeros. Hence I collected 2 and 5. Here I have 24 5s, here 97 twos, but in this I took only 24 twos. Remaining I did not collect to get 0 because no 5 is there. To form a 0, 1 to 1 5 should be included. Here we have twos but we don't have 5s. Hence this many twos, this many 5s I collected. I answer to this question. Right. Now let us go to one more application based on this factorial of a natural number. See, let us see that. 1 into 1p1, 2 into 2p2, 3 into 3p3 and so on n into npn. Now, you know students, npn is equal to n factorial. npn is equivalent to n factorial. You know, npr is equal to n factorial by n minus r factorial. If r is equal to n, now denominator part becomes 0. 0 factorial. 0 factorial is equivalent to 1. So this result will be n factorial. So you know, see, this can be also written as 1 into 1p1 1 factorial. Now 2 into 2p2 2 factorial. 3 into 3p3 3 factorial and so on plus n into n factorial. Hereafter I would like to express this 2 as 2 minus 1 into 1 factorial. So this 2 can be written 3 minus 1 into 2 factorial. This 3 can be written 4 minus 1 into 3 factorial and so on. This last one can be written n plus 1 minus 1 into n factorial. I hope you have understood this, students. Now let us go for simplification. From this step to this step, it has come. You know, 1p1 can be written 1 factorial, 2p2 can be written 2 factorial, 3p3 can be written 3 factorial. NPN can be written n factorial. In the next step, these two I have written as 2 minus 1, this two I have written as 3 minus 1, this I have written as 4 minus 1 and so on. Last one can be written n plus 1 minus 1 into n factorial. When you send 1 factorial inside, 2 into here 1 factorial minus 1 into 1 factorial, which becomes 1 factorial, plus here 3 into 2 factorial minus 1 into 2 factorial can be written minus 2 factorial. Here 4 into 3 factorial minus 1 into 3 factorial can be written as 1 3 is a 3 factorial, and so on. Last one, n plus 1 into n factorial minus n factorial. Now 2 factorial, 2 into 1 factorial can be written 2 factorial minus 1 factorial, plus 3 into 2 factorial can be written 3 factorial minus 2 factorial. 4 into 3 factorial can be written 4 factorial minus 3 factorial, and so on. N plus 1 into n factorial can be written n plus 1 factorial minus n factorial. So suppose if you would have to simplify only first two terms, here plus 2 factorial minus 2 factorial cancel, big number minus small number is left. Suppose if you simplify first three terms, so here plus 3 factorial minus 3 factorial cancel, big number minus small number will be left. Like that, if you keep on simplifying all of them, so at last n plus 1 factorial big number will be left and small number minus 1 factorial. So 1 into 1 factorial plus 2 into 2 factorial plus 3 into 3 factorial and so on, n into n factorial can be written as n plus 1 factorial minus 1. 1 factorial also can be written as 1. So in the question paper, we may get like simplify this up to 10 factorial. Means in the place of n, you would have to replace 10. In this simplification, they may ask us up to 50. 50 into 50 factorial. Just replace n by 50. Like that, you can answer to this kind of questions. Thank you.